Hi, I'm Kat and I'm with Firebase. Today I'm just gonna go over a bunch of things in Swift to give you a feel of what the language is like, why you might want to use it, and a bunch of tools that you can play with. So let's go with a general overview of what Swift is. So, one thing you might know about Swift is it was made by Apple. One of the general designs of Swift was that it had to be as fast as Objective-C and it needed to interoperate with Objective-C. It has a bunch of modern features. One of the things it does is it checks for nil, and this is built into the language itself, so you have to do it. This makes everything a lot safer. And you can do things like return multiple values. One of my favorite things is that methods are way less awkward than Objective-C. It looks, like other programming languages now. Swift now has a concept of generics. It also has private variables and methods, as well as protected ones so that you can only access them from within the same project. The interoperability with Objective-C is there. It's a little bit clunky sometimes, but if things don't work, try just adding @Objective-C, and there's a pretty good chance that things will work. It still maintains the concept of reference counts, so if you're coming over from Objective-C, you'll still see this concept of weak, strong, and unowned. So why not Objective-C? What's wrong with it? Well, I'm going to paste in a little bit of Objective-C code here, and we can take a look at it. So here I just pasted in some code. Here you can see we have XYZ. Everything in Objective-C, or before iOS 8, basically needed to be prepended. Nowadays, you don't have to do that. You had this @interface stuff, you had these @properties, you had all these @signs. And that's just like a hallmark of Objective-C. Other things you might notice here is a method declaration. So it returns void as this minus sign in front, which basically means it's a class level method. It's got these weird square brackets everywhere. And it just doesn't look like pretty much any other programming language you've probably dealt with. All right, and so as an overview, here's a bunch of different topics that we'll go over. It seems like a lot, but I promise a lot of it will go by really quickly. A lot of it is familiar from other programming languages. For example, variables and constants, they show up in pretty much every programming languages. You have functions, you have classes in a bunch of programming languages, and we'll just see how things work out in Swift. All right, so to create a variable, we can do something like this. Here we have var, which stands for variable. Language is the name of our variable. It's a string type, and we've set it to be Swift, the string Swift. And over here, this playground, which is what I'm coding in, is super helpful and tells you just what your variable looks like. You can also drop the type. Swift is a language that will infer type. And this automatically knows that it's a string because you've set it to Swift as well. You can also do constants. And so a normal variable, you can reassign it to be other values, but with a constant, you can't do this. So here I can set language. And here, this gives me an error. And it says, cannot assign to let value const language. Just means that I have a constant. We can also do things like set pi to be 3.14159. We can also use Unicode characters. So I can create a snowman corporation. Ta-da! Theoretically, I can also do this. But I can't actually. Maybe someday that functionality will actually get added. All right, so I know you've been waiting for printing. The first thing I was supposed to teach you was hello world, and I didn't do that. Sorry. We're gonna do it now. So I can put a print line and say, hello, snowman. And you'll see here that it prints the string, but how do you know that's any different from these strings over here? Well, if I pull up the console output, you'll see that only hello snowman got printed out. All of these things are just telling me information about my variables. And this is where the actual output shows up. You can also print variables. You can also print expressions. You can also directly print variables. And all of it shows up in the console output. Alright, so another concept that Swift has is tuples, and tuples basically allow you to bundle up a bunch of values together. You can have the same or mixed types in a tuple. So here I just have a tuple, it has 3 and 4, and like I said, you can have mixed types. To access what's inside of the tuple, we can do tup_a.0 and tup_a.1. And you can see on the side that we have 3 and 4. Why we don't use square brackets, I don't really know, but it's a character shorter. Alright, so now let's talk about arrays and dictionaries. They are, unlike in Objective-C, they are typed. And like with other variables, you can infer their type. Here I've created an array, it's called supported, and in this array I can only store strings. So here I've stored the string Swift. I can add to this array with another array, and over here you can see that it's just appended the values to my array. If I wanted to create an empty array, I might think that this was possible, but the problem with this is that it isn't typed, so I have to give it a type. So here we have an empty array, which can only store strings, but we started off with 0 elements in it. Dictionaries are also typed, so I can list some airport codes and where they are. And you can see here I've used square brackets on the outside. The colon separates the key from the value, and the different key value pairs are separated with a comma. I can add other values to my dictionary. And to create an empty dictionary, I have to do something similar to what I did with arrays, so I have to type it. So here I've created an empty dictionary. You can see here that I've set the type so that the key is a string and the value is a string. And inside of it, there are no pairs. And this helpful thing on the side says there's no pairs. So to print from arrays, I can just use it like another variable. And you can see the string that's printed out over here has the first value that's in supported. For dictionaries, it's unfortunately a little less straightforward. You can see here I got a little bit confused by my quotation marks. So instead, I can do something like this. And here it says, I want to fly to San Francisco. But wait, what in the world is this exclamation point? Well, we will get to that in just a little bit. Alright, let's talk about conditionals and loops. So these are pretty straightforward. You've seen them probably in a bunch of other programming languages. One thing to note is you don't need parentheses around your if expression. So I might write something like this. So this probably looks like any other if loop you've written. And you can see here that it evaluated correctly. It prints out it's positive because 17 is a positive number. Switch statements are pretty cool in Swift. Two things that Swift makes you do is that it breaks automatically after each case, but you can specify a fall through. And the other thing is it must be exhaustive, so you have to cover all of the possible cases. So if we were to switch on the random number again, and again you see I don't need the parens there. I can do a normal case, so here's the case when it's 0. I can also combine cases together. I can also create a range of numbers. And here, the ... represents the numbers 4 through 9 inclusively. I can also specify a case with a fall through. And so this fall through is so that I don't have to put a break after each of the normal cases. And since, for whatever reason, the numbers keep going on after 10, and there's numbers smaller than 0, I have to specify a default case, unless I really want to spend all my time typing out all of the numbers. So with this default case, that error that'd been nagging me on this side finally went away because I've covered all of the possible numbers. You can loop over a bunch of things. So you can loop over strings by character. And here we're going to print out all of our board members of the Snowman Corporation. Let's pull up our console output. And you'll see that because we had 3 snowmen in our Snowman Corporation, we get this looped over 3 times. And I don't know, snowmen kind of all look the same, so you can't really tell your board members apart. You can loop over a range of numbers inclusively. And you can see here that all of the numbers got printed out. But what if you don't want to include the 5? You can also print numbers that include the first number, 1, but not the last number, 5. That looks like this. And so here you can see that we have the numbers without the 5 at the end now. And you can remember this because this is a little less than sign, so it goes all the way up to less than 5. We can also loop over arrays. And so here we can see that we support Swift, Java, and Objective-C. We can also loop over the key value pairs in dictionaries. And so here you can see all the places and what their airport codes are. If you just want to list all the places without the codes, you can use an underscore in place of the code. And so you can see here that the place I'd like to go is Berlin, San Francisco, and Boston. And the underscore just says that I don't need to remember what the code is, and it just disappears. All right. So remember when I wrote some code that looked like this? And I said, let SFO be the airport at SFO, and I printed this line out, and I had this exclamation mark. Well, I'm just really excited to fly to San Francisco. I'm also really excited for optionals. What are optionals? Well, let's take a look at what happens when I say Airports 1 is airports of SFO. You'll notice here it says some San Francisco instead of just San Francisco. What's going on? Well, if I try to get LAX instead, you'll see that I get nil instead. So what an optional is that I might have something, in this case a string, or it might be nil. The type of it looks like this. And so the only thing different from this and a string is that this one here has a question mark. It basically says, I don't know if I'm a string. I might have a string, or the other option, and the only other option is that it's nil. So wait, what really is up with the exclamation point? Why do I have the exclamation point? I now have this question mark too. Well, to get something out of an optional, I have to check first whether it's a string or if it's nil. So to check whether or not it's nil, I can just do an if statement. That looks pretty standard. I'm checking whether or not airport 2 is nil. And once I'm certain that it's not nil, I can print it out. And so the exclamation point says, I am really certain that this is a string. Just give me the string and forget about the fact that it was ever an optional. So what happens if I use the exclamation point when it's actually nil? Well, over here we can see that airports 1 is nil. So let's see what happens. You'll see that I'm not getting anything printed here, and if I pull up my console, I'll get Fatal error! Unexpectedly found nil while unwrapping an optional value. That just means I tried to use the exclamation point when it was actually the value nil instead of having a string there. Another way I can do this is to type something like this. Here I have an if-let statement instead of just a normal if statement. And what this basically says is I'm going to set the value of airport's BOS to name. If it's not nil, then I will execute the if loop. If it is nil, then I'll skip it entirely. So here it says I really want to go to Boston. But if I change it to LAX, we'll see that it skips the loop entirely. Another concept that comes up a lot is the implicitly unwrapped optional. Alright, so we can also have implicitly unwrapped optionals. That just means we don't want to put exclamation points everywhere and we don't want to put our question marks everywhere, so we're just going to do it once. This isn't a terribly good example because the airport code BER may or may not be in airports. What this is really useful for is in your view controller, you might want to have a bunch of properties in your view controller, but you don't want to initialize them until view did load. We'll talk about classes later, but usually you need to instantiate everything in your initializer. And now that I've done this, I can just print it without all the exclamation points or if statements. Alright, so now let's move into functions. I might want to have a function that prints out a greeting. Alright, whoa, hello world. We've made the call to greet, and now we see that hello world has printed out. But this seems like a lot of typing. Didn't I say something about types being implicit? Yes, I did. So we can actually drop the void. And the return type since it's also void. And we can call it the same way. I can add parameters and also a return type that isn't void. And now I can call this method. And here I get out my string. Hello, Firebase. I can also set a default value. So if I call this with no parameters, I will get the default greeting, hello world. I can also return multiple values using the tuple. This might be useful if I have an error code and an error message I want to return. Here I have no error, everything is a success. So I can get it by getting the status. And then I can access the values by saying status.0 and status.1. And you'll see that I get 200 and success. I can also do something like this. And this will allow me to access it by typing in code and message, which is a little more descriptive than status.0 and status.1. I can also store it as a variable. And I can print it out just the same, but now I can set my code to be something else as well. This works with both constants and variables to get out multiple values from a function. Another awesome thing is you can type variables as functions, so you can do something like this. And so here I've just stored the previously defined build greeting function that we built before, which says hello to two different things. And here I'm just calling it using function holder instead of build greeting. Another awesome thing that Swift has is closures. We can do something like create a greeting printer. And I can call this the same way I would call a function. Wow, this is the millionth time I've said hello world. And because Swift likes dropping all of the things that seem unnecessary, we can do something like make it even simpler. So what were those parens and those arrows and those ins? Well, those allow us to specify the parameters that we want to pass into our closure and return from our closure. So instead of having a greeting printer, let's have a greeting returner. And so instead of having things print out with this, we will actually get returned a string. So earlier we talked about how Swift is typed, but a lot of the types can be inferred. This is also true of closures and the return types. So instead of writing a greeting returner and naming all of the different types, I can actually leave out a bunch of this. You'll notice that we don't have a return keyword at the last line. This is because the closure will just return whatever's on the last line and infer that as the type of the return value. For really short closures that don't need named parameters, we can write something like this. You'll notice here that we had to set the type of the constant so that it knows what parameters are coming in and what it's returning. This is so that it knows that it's a closure, since we don't have any other information about it. You'll notice here the $0 basically says pull out the first parameter. In this case it's a string, so it'll put in the string. So here we've returned hello universe. We can also pass closures in as parameters to other functions. Here I've just written a simple repeat function. So it'll take in count, which is a parameter, as well as task, which is a closure, and it'll perform task count number of times. To call this function, we can do something like this. And if I pull up the console, we'll see that it says hello twice at the bottom. It also informs us over here that it's been called twice. In Swift, we also have a new concept, which is the trailing closure. This means if the closure is the last parameter passed into a function, we can write it in a different syntax. We can write the same thing as above, like this. And you'll notice here on the side it says it got called twice again. This kind of looks like how you would write an if loop or a for loop. So this is a really good way of introducing new control structures, like repeat, into your code. Alright, now let's dig into structs and classes. They are pretty similar to classes in Objective-C, and they'll feel pretty similar to each other, but I'll go over the differences. So structs, to begin with, are a good way of grouping data together. Here I'm going to define a point struct with an x and y property. Here I've also provided them with default values, 0.0. You'll also notice that I used var to define the property. This means that it's a variable and anyone can modify it. So I can create a default point this way, and if I show the x value, you'll notice that it's 0. I can also initialize it with different values for x and y. I can also change the value of just one of the properties. This way of initializing structs comes by default, so if you provide it with a default value, you can call it with no parameters, but if you want to initialize it with other values, you can also do that. But we don't have to provide the default values, so we can also define a struct this way. Since there's no default value, we have to tell Swift what the type of this property will be. Since we don't have default values, we also can't use the default initializer, but we can still initialize a struct of type size. You'll notice that the names that we pass in for the parameters in the initializer here are the same as the ones for the properties. I'm also going to define a rectangle struct that uses the point and size struct so we can talk about some other interesting features. One of the cool things is computed properties. This allows us to expose more properties which are just computed from properties we already have instead of storing more and more things. Here I'll define the upper left computed property. So this is a getter that gives us the upper left point. We can also use upper left as a setter to change the center, which is a property we actually have. So I can create a struct rectangle with the center and the size using the point and size that I previously had. And naturally I can change the center or the size since they're properties. But now I can also get the upper left. And you'll see here that the values are actually computed from the center and the size. And like I said, we can also use it as a setter. And we can see that the center has indeed changed. Structs can also have functions. So here I'm going to add a description to our rectangle. Here, this is the description. It takes in no parameters and it just returns a string. So I can call that function too. We can also add static functions for things that make sense for rectangles. Maybe we wanted a unit square, so given a center, we can create a unit square. And now we can call static function from rectangle. Here we've centered it on the origin. You'll notice that none of these functions actually change size or center. It turns out we can't do this without adding the mutating keyword. That looks like this. This mutating keyword here just allows the function to actually mutate the properties center and size. And now we can actually change where our rectangle is centered using moveRight. So why do we need the mutating keyword? Well, if we want our rectangle to be constant or immutable, having the mutating keyword basically ensures that Swift can tell us not to use moveRight on a constant. So let's try that out. So here, constant r is a constant, and we're trying to call moveRight on it. Let's see what the error says. Oh, look, it says it's immutable, and so you can't call moveRight since it's mutating. You also can't change the center or the size. And here's the error that says you can't. So structs are really good at organizing data, and we can use let to make constants so that the data doesn't change. Now let's talk about classes. They're pretty similar to structs, but instead of using struct keyword, we'll use the class keyword. One difference is that if we don't provide a default value, we have to provide an initializer. We don't get a default initializer if some of the properties don't have default values. So how do we define an initializer? Well, that looks like this. So we'll just initialize it and say that the gas always starts out at 10. We can also define functions that mutate these properties without the mutating keyword. And here we just decrement the gas. We can also define functions that are like static functions from the struct, but instead of defining static functions, we define class functions. Why? I don't really know, but that looks like this. And so here we just say if we call vehicle.isTransportation, we'll always return true. So let's try out this class. So here I've initialized the class. You'll notice that we don't have to pass in a value for gas, since gas is always defined to be 10 in our init function. We can use gas. We can check out how much gas there is. And we can call vehicle.isTransportation, which is always true. We can also create subclasses that override functions of the parent class. That might look like this. Maybe cars use 1/10 of the gas a normal vehicle uses. We can also add new properties. And so long as we give them a default value, we don't have to also create a new init function. So since we defined v over here to be a variable, we can use it for our car subclass. And we can use gas. And since it's actually a car, it'll only use 1/10 of the gas. However, since the type of this variable is a vehicle, we can't just call speed on it, we have to cast it. If we were to try to call speed, it would give us an error. Oh look, it doesn't have a member named speed because it thinks it's a vehicle. But if we cast it, it works out and it says that our speed is 0. So remember how we went over switch statements and how they had to cover all the cases? Well, we can also use switch statements to match on the kind of class, so long as we cover all of the vehicles. That might look like this. So here, in the case that V is actually a car, we can cast it to a car, and this is similar to the optionals, the if-let statement from optionals, and when we know it's a car, we can set the speed to 3. Otherwise, it's some default vehicle, and, well, we know we can always use gas. So what are the differences between classes and structs anyways? Well, I'm gonna go use the rectangle struct that we defined before and the car classes so that you can see what the differences are. One of the differences is that structs are a value type rather than a reference type. What that means is if I create one rectangle, and I try to copy that rectangle into another rectangle, rectangle B and rectangle A are actually separate rectangles. So if I go and change the center of one of them, rectangle A remains the same. You'll see here that it's still centered on 0, 0, where rectangle B is centered on 3, 3. This is not true of classes because they're a reference type. Let's show an example. So if we create one car, and we create another car by setting it to car A, if we change the speed of one car, it'll show up in the other car. And let's check out the other car. Whoa, look, the speed of both of them is 3, even though we only set it in one car. Another difference that I kind of touched on before was the immutability. So with structs, if we use a let and make it a constant, we can no longer change the properties of the constant rectangle. If we try to do so, we'll get an error. But if we do the same thing for a class object like the car, and we try to change the speed of the car, this actually works out just fine. So what constant means for a struct means that the data itself will be constant. For a class, it just means that the actual object cannot change, but the properties can. So when talking about cars and vehicles, I briefly touched on casting. Let's dig a little deeper into it, since Swift actually uses casting with optionals to make casting safer. To do this, I'll be using a dictionary that can store anything. And here I'm just typing my dictionary, so the key will be a string, but the value might be anything. And we'll start it off empty. But let's add a few things. And so if we try to pull things out, we might rely on inferred types. And here you can see that we actually got an optional back, which says some candles. This again is just checking whether or not it's actually in the dictionary. If we passed in something that wasn't the string or double, like if we passed an integer, it would have returned nil. So we can grab out other dictionary values. Now that's pretty weird. We used any value, but we managed to store an optional, which is a string, or an optional that's a double. What's going on? Well, this any type over here basically says it can store anything. So the type of this is actually an any optional. We could do this to make the type explicit instead of inferred. Well, that's not really useful. What if we wanted to pull out the double and then do some division? We could do that like this. And now we get 3.0 instead of the sum. This is because it cast it from an any optional to a double. But if we don't know that it's actually there, we'll run into trouble. So if we tried to get a different dictionary value that isn't actually there, you'll see that we actually get an error. So if we open up our console, fatal error, unexpectedly found nil while unwrapping an optional value. That's because this used to be an optional, but we're casting it to a non-optional. Well, that's not really great. And what if we grab the string? By accident, say. What happens there? Well, we also get an error. This one looks a little scarier. It says execution was interrupted. Actually, I don't know which one's more scary. The other one said it was fatal. So the point being, well, this isn't really a great way. So how can we do it better? The best way to do it is like this. The as question mark basically says, if it is a double, then cast it to a double. If it isn't a double, whether that's a string or a nil because it's not actually in the dictionary, then it won't cast it to the double and instead it will return nil. So you'll see again that we have the sum 3.0 instead of the straight 3.0. But this also means if we were to do something like grab the string value, and we were to use the same thing and try to cast it to a double, and we were going to do the same thing and try to cast it to a double with the as question mark double, we'll get nil instead of that angry looking error. And if we try to grab something that isn't actually there, we'll also get a nil value. So the as question mark allows us to get something from the dictionary if it's there, and if it's not there, oh well, and if it's not the right type, oh well, it'll return nil. So that was casting using optionals. Highly recommended since it'll keep your code safe and you'll know the types of everything. One thing that might be confusing starting out is parameter names. There are a couple different ways of defining functions, whether standalone or as part of a class, or as the initializer, and they have different defaults for whether or not you need to throw in the parameter name. So I'm going to go over that quickly. So I'm going to just define a quick function. Super boring, but it'll illustrate some key concepts. Like this A and this B here are parameter names. They're internal parameter names because I can use them inside of the function. And so I can call the function, and I should get the number 7. But when we initialized the point struct from before, and we didn't use the default values of 0, you might remember that we needed to put in the x and the y. These names are called external parameter names. That's because they're used when we're trying to call the method. We can add external parameter names to any old function. And so we'll now have an error when we called our function, but we can just add the external parameter name. And so here you see that first is used when I'm calling the function, but inside of the function I use a for that value. Now a shortcut, if I wanted it to have a and b show up here instead of first and second, I could type a and b here, but an even easier way is to use the pound sign, and so that's just a shortcut. That's a little advanced tip, but the key thing to remember here is when defining a normal function, you don't have to use external parameter names. One really cool thing is that you can actually name the outputs as well. So remember that get status? Well, let's use that again. But this time we're going to use named parameter outputs. You'll notice it looks a little bit like the inputs. We put in what we want the name to be and then what the type is. But this time when we get out our value, instead of using .0 and .1, we can use .code and .message. Of course, we can use the .0 if we want to, but code is a lot more descriptive. And that's it. Now you know enough to be dangerous with Swift. Have fun.